Okay everyone, so we're looking at triangles, and there's two different ways you can classify triangles. You can classify them based on their sides, and you can classify them based on their angles. Now let's have a look at this first triangle, the scalene triangle. The scalene triangle is based on its sides, and not any two sides are the same length. Each side has its own unique length. If you can see those little dashes on the side, in geometry we use these to show sides that are the same length where we're not showing numbers. And you can guess it here with the isosceles triangle. It has two sides that are exactly the same length. So you can see this one again, they've both got the one scratch or the one mark on the sides to show that they are the same length. The equilateral triangle it's got all three sides there. They're exactly the same length. Now this may not be a perfect representation, but you can see that two marks on each side indicate that they should be the same length. So here's something that you can do as a little follow-up activity. With a protractor, measure the corners of the equilateral triangle. They're very difficult to draw, so you may want to print a picture of one out from the net, and using a protractor, measure the corners and see what you notice about the corners of this triangle, the equilateral triangle. Again, with the isosceles, the one that has two sides the same length, measure the angles in the corners and see what you notice about that. And you could do that again with the scalene triangle as well. And this will help you understand the relationship between sides and angles. So there's another way to classify triangles, and that's based on their angles. And we've all probably learnt this from about year 2, the right angle triangle. And that's where one of the angles has a right angle in it. And you can see that there. Well, you're familiar with that one. You may not be familiar with the acute triangle or an acute angle triangle. And that's where all three angles are smaller than a right angle. Do you remember that? The acute angle? It's an angle that's less than 90 degrees. And we can remember this because it's got the word cute in it. You could think it's a cute baby angle because it's not very big. It's quite small. That might help you remember that. Now here we've got the obtuse. An obtuse triangle. And an obtuse, you may have heard of that angle before, an obtuse angle. It's an angle that's greater than 90 degrees but less than 180 degrees. And here in this triangle, you've got the obtuse angle, which is greater than that 90 degree section. And I can show you that with holding a 90 degree angle to it. It is greater than that angle. So here's a challenge for you. There are two different ways to classify triangles. Just to go over that again, we can classify them on their sides, the similar sides, or their angles. Now, here's a question. Can a right angle triangle also be an isosceles triangle? Meaning that it's got a right angle in it, but can it have two sides that are the same length? And what about this one? A obtuse triangle, a triangle with an angle greater than 90 degrees. Can it also be a scalene triangle? Can it also be an isosceles triangle? Could it be an equilateral triangle at the same time? So I'd like you to go and compare these three at the bottom and the three at the top and see, are there any similarities? Could it be a triangle be a right angle triangle and an equilateral triangle at the same time? That's for you to discover. Once you've done that, you might want to make a table like I have just here and go through. And acute triangle, I have my triangles based on sides up the top and my triangles based on angles going down the side. An acute triangle. Could a scalene triangle be an acute triangle? Could an isosceles triangle be an acute triangle? If you think so, if you've drawn it and discovered it and you think there is, give it a tick. An obtuse triangle. Could it be an equilateral triangle? If you think it's no, then give it a cross. And go through and discover what you can about these triangles and record your data using a table like this.